Assalamu alaikum wa rahmatullahi wa barakatuhu, and welcome to the monthly Primetime webinar. My name is Munazza and I will be your moderator today. Today's Primetime is about Muslim contributions towards advancement of civilization. Before we start, we have a couple of announcements while we wait for others to join. Next, please. Slide, please. MCNA offers a variety of programs throughout the year, and some of them are Primetime, which is a free monthly program addressing current topics and trends for kids. This Primetime is an example of it. We also have Primetime for adults, which are parents, and an ADHD talk will be for the parents on October 25th. MCNA also offers youth courses during the spring and the fall. Coming up program is about social media. There is also a journey through the Quran course during the month of Ramadan. We also have a children's magazine called Companion. Companion is a magazine for kids written by kids all across the United States. Our next companion theme is about body shaming and its effect on physical and mental health. Some of the subtopics you can write about are food disorders among children and adults, healthy versus skinny, effects of preservations, practical ways of balancing activism and spirituality, reflections from various Muslim scholars on balancing spirituality and activism, spirituality as a self-care necessity. If you're creative and good at writing, please send your writings. Okay, next slide, please. And MCNA YMJ has many local sessions in different chapters and regions throughout the United States. For more information, please visit our website for chapter locator. And the next two slides, actually. Our MCNA YMJ YouTube channel is a great resource to watch our program recordings. Make sure to like and subscribe to our YouTube channel so you can be notified when new videos are uploaded. Last but not least, please like and follow our Facebook and Instagram pages for our upcoming programs, details, and updates. All right, let's start today's program with Tilawat al-Quran, inshallah. Bismillahirrahmanirrahim. الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين. Okay, today's primetime topic is Muslim contributions towards the advancement of civilization. In the 17th century, as most of Europe continues its descent into a long period of intellectual dormancy, a quite yet powerful academic revolution is erupting in another corner of the world. Over the next centuries, the geniuses of Muslim society will thrust the boundaries of knowledge forward to such a degree that their innovations still shape civilizations to this day. Today, the influence of thousand-year Muslim civilization is clear to see in medicine, astronomy, architecture, engineering, mathematics, chemistry, history, geography, psychology, as well. Today's customs, fashions, and tastes. Today's speaker is Anzar Latif. He was born and raised in the DFW Metroplex. He completed his bachelor's in electric engineering at UTD, where he is currently enrolled in 2 master programs. Besides taking Islamic studies classes in the DFW area and his local masjid EPIC, he continues his study of the Quran locally in Arabic with the retreat. He has also taught classes in Quranic recitation and basic Arabic with the retreat. He has a special interest in history, especially Islamic history, ancient history, and the history of languages and religions. He has contributed research to multiple Islamic scholars on the topic of history, and he has taught history classes at the EPIC Masjid. Please welcome our speaker.
Assalamu alaikum. Thank you for the introduction. Before we start, let me just address some of the questions. One of them is Assalamu alaikum wa rahmatullahi wa barakatuh. Wa alaikum assalam. Another one is Assalamu alaikum, also wa alaikum assalam. And the session is starting now. Okay, so today we're going to talk about Muslim contribution to the advancements of civilization, right? The advancement of technology, the advancement of knowledge, the innovations. We're going to be talking about all that. But first, before we get to that, in order to understand how technology advances, I want you to answer these real questions. First off, 1 plus 1, 2, right? 2 plus 2 is 4. The reason why I'm trying to get you to do this is to make a greater point, okay? 4 plus 4 is 8, 8 plus 8 is 16, 16 plus 16 is 32, 32 plus 32 is 64, then 128, 256, 512, and 1024. As you notice, every time you add, the number that you get is higher and higher. You get a higher value based on what you already have, and you get more, and you got that based on what you had before. And this is called an exponential increase. And just like these numbers are increasing exponentially, technology also increases exponentially. For example, you're all familiar with a smartphone. All of you should have all of your parents should have smartphones, right? But in order to get smartphones, we couldn't have gotten them without the technology behind cell phones and personal computers. And we would never have gotten cell phones without the technology behind telephones combined with radios. And we never got the technology for telephones without telegraphs and microphone speakers. In other words, everything that we have is based on what came before it. We won't be able to get anything without having knowledge of what the people before us had. And because of that, as you can see over here, it just increases exponentially. It just increases and that's why you probably would look at stuff like back in the day, because now you have smartphones, and you'll be probably looking at people who the Muslims from the 8th century, from the 800s, and the Muslims from the 1400s, and you'll probably think they're the same. But guess what? 1,000 years from now, people would think that smartphones and telegraphs are basically the same thing, because they'll be so advanced that smartphones will be just like telegraphs to them. Now, advancement of, as I just said, advancement of technology is based on taking what already exists and advancing it, building off of it, taking off the bad and or keeping the good and making it better. And the Prophet ﷺ used the knowledge available from even his enemies in order to advance the Muslims. The first example is after the Battle of Badr, the Prophet freed the prisoners who taught Muslims to read and write, sallallahu alaihi wasallam. Right? The Muslims who were imprisoned, the Muslims won the battle, and the people who were imprisoned, if they taught 10 Muslims to read and write, they were freed. Then in the Battle of the Trench, Salman al-Farsi told the Muslims about trench warfare, about digging trenches for defense, and the Muslims adopted that innovation. However, the most famous example of the Prophet adopting innovation from surrounding civilizations was the Battle of Hunain. The Prophet was fighting the Hawazin and Banu Thaqif, the people of Taif. You know, those people who threw the rocks at him after Khadija and Abu Talib died. He was fighting them, and the Battle of Hunain. Now, during the battle, the Prophet adopted technology from outside Arabia. He like, for example, the stuff the Romans were using, the Muslims used a catapult. The Muslims used a battering ram. The Muslims used a testudo. This is a picture of, these are pictures of all of them, right? You can see over here, there's a catapult, a battering ram, and a testudo, which is basically a shield formation to defend them. But this is all innovations and knowledge from other civilizations that the Prophet adopted, right? Because in order to get far, in order to get better, you need to take from those around you and improve it. And that brings us to paper. See, there was a battle called the Battle of Talas between the Abbasids Khalifa and the Tang Chinese Empire. Now, when the Muslims won this battle, the Buddhism stopped growing. And Indian Buddhism and China Buddhism became completely different kinds of Buddhism. Okay? And then, of course, the Turks started converting to Islam. But the most important thing for us, for this class at least, is that the Muslims discovered paper making from the Chinese. The Chinese used to have paper. Before we had paper, Muslims used to write on animal skin called parchment. They used to write on papyrus, which is basically like plants stitched together. However, paper was so much easier and made everything so much easier. Now, the Chinese didn't really write on paper as much. However, the Muslims did. The Muslims realized that, oh, we can write the Quran on paper. Wait, we can write other books on paper. We can write a lot of things on paper, and it's not going to be as big because because we were writing on parchment, copies of the Quran were as big as your sofa. Now now you can have small copies of the Quran that you could carry around. And that's what paper making did. And then not just we wrote the Quran, we wrote other books too. Because paper lasted longer and everything. And that brings us, that brings us to the people who did the knowledge, okay? Now first, we have Al-Khwarizmi. Al-Khwarizmi needed to calculate the inheritance. As you can see in Surah Nisa, ayah number 11 and 12, it talks about the rules of inheritance. And that alongside some hadith, the hadith are where we are the basis behind Islamic inheritance laws, and that's how we calculate the inheritance, right? However, we needed to make it easier to calculate in order to follow the Quran properly. And not just that, we also needed to calculate the zakat. And so Al-Khwarizmi looked at these. He was like, oh, Muslims want to follow the Quran, and they want to listen to Allah and calculate inheritance and calculate zakat. So he developed something called algebra, which comes from the Arabic word al-jabr. He took the knowledge that the Indians and the Greeks had, combined it to make something new, and now he is called the father of algebra. He took the knowledge from before and revolutionized it. And he also developed algorithms to devise solutions to arithmetic problems. I mean, like simple like addition, multiplication, division. He found like steps to make problems easier to solve. And he also wrote a book on spherical astronomy, which was based on like astronomy, which helps you to calculate the Qibla. In other words, Al-Khwarizmi, his full name is Muhammad ibn Musa Al-Khwarizmi, made scientific and mathematical advancements in order to make Islam easier to follow for the people, in order to make it easier to listen to Allah. In other words, algebra was invented because people wanted to follow the Sharia. People wanted to follow the rules that Allah sent down, and therefore algebra was invented. One thing he also did is he adopted the Indian numerals, and he adopted it and popularized it. Because what you had before is before you had these numbers, basically people wrote letters as if they were numbers. Alif meant 1, Ba meant 2, Jim meant 3, Dal meant 4, etc. Right? People used to use letters for numbers. Al-Khwarizmi basically was like, you know what? The Indians have this really good way. Now let me just jot it down. However, as it was copied, the handwriting changed, right? In the East Arabia, like Iraq, that area, you have the numerals that we see in Arabic today. on the, you see this middle column over here? That's how it looked in the Eastern Arabia. However, the Arabs of the West, so Libya, Morocco, Algeria, and Spain, where all the Arabs were living, where a lot of Arabs were living, their handwriting of numbers started looking like this. And then when the Europeans started learning from them, it became like this and like this, right? In other words, it was directly borrowed. You can see the way it was borrowed. It was like differences in handwriting, basically. And that, yeah, so you can see how basically Al-Khwarizmi revolution, Al-Khwarizmi basically popularized the Arabic numerals, and that's why you don't see the Abjadiyya numerals. You don't see Alif, Ba, Jim, Dal to be letters anymore, to be numbers anymore. Now they're just letters. Next, we'll get to the Banu Musa brothers. So their dad was Musa ibn Shakir. He was a robber who became friends with the Khalifa, and he got a job as an astronomer. So he basically regretted his actions and made his life better. And now his sons were actual scientists and stuff, and mathematicians. Their names are Muhammad, Ahmed, and Hassan, and Al-Hassan. They wrote a book called the Book of Ingenious Devices. Okay. They also wrote the book on the measurement of, the book on measurement of plane and spherical figures. And they decided, okay, when the Greeks, so basically they were reading Greek stuff, they were translating Greek works, and they were like, you know what? We can make this better. And so now when you see volume, you're like, oh, this volume is this many cubic centimeters, stuff like that, right? Then the idea of adding numbers to volumes came from the Banu Musa brothers, because the Greeks only used ratios. They were like, oh, this cube is the side times the side times the side. The Banu Musa decided to basically add numbers instead, to describe it with numbers. And one of their inventions is, I have a diagram here. As you can see, this brown thing over here is a floating device, okay? The floating device is connected to a metal, which is connected to a hook, okay? And the hook is connected to a little faucet thing, right? Now, the water underneath is connected to another reservoir, another water. And so if people start taking water from here, eventually, the more water is taken out of here, the water over here goes down. So the brown thing goes down, okay? The floating goes down, and eventually it will go all the way down, that the metal will come down and it will rotate the hook, which will make the faucet turn, which will make the water come down. And then as the water comes back, as the water comes down, the water in here comes back up, meaning the water in here also comes back up. So it'll come back, and then when it comes back up, this will close. That's one of the many things that the Banu Musa brothers invented. This is basically the basis behind plumbing and a lot of other sciences that we basically need to survive now. See? And then, yeah. Next, let's get to Abbas ibn Firnas. Ibn Firnas was one. There's a story that he basically did the first intercontinental flight. He basically flew from one country to another on basically a glider. However, the story goes that he hurt himself. However, greater contributions that he made as well is that he found a means to manufacture colorless glass. Any of y'all who played Minecraft or RuneScape know that you make glass out of sand, right? However, the way to make it without any color, now that we have windows and glasses, is because he found a way. Ibn Firnas found a way to make it colorless, a much easier way to make it colorless. And one thing he used out of these was made something called reading stones. If you see this picture over here, you see that they put a glass ball over a letter to make it bigger. The reading stones is basically a precursor to the glasses. I'm sure a lot of y'all wear glasses, right? The main reason y'all wear glasses is because of the reading stones that came before. Because Ibn Firnas figured out that, oh, I can make colorless glass like this, and I can make it easier to read. Then someone later was like, you know what? Instead of putting this piece of glass on the paper, maybe I can put it just next to my eye. And now you have reading glasses. Now, one of the governors was Ahmed ibn Tulun. He originally was a Turkic slave soldier. So this was a time that slavery was allowed. This is a time that slavery was common. And one thing you need to remember is that slaves in the Muslim world were not at all like the slaves in America. It was nothing like that. Because this Ahmed ibn Tulun became the governor of Egypt. In other words, in the Muslim world, slaves became politicians, became leaders and stuff, because the Mamluks were completely different from like what you think of slavery in America. In the Muslim world, it was completely different. But Ahmed ibn Tulun became governor of Egypt, and when he became governor of Egypt, he made Egypt independent. Basically, he became the one in charge of all of Egypt. In other words, it was only in the Muslim world was one of the only places where a slave can become basically a king. And that's what Ahmed ibn Tulun basically did. And while he was in charge of Egypt, he founded the first hospital that provided free healthcare. In other words, he made a hospital that anybody could come to and they didn't have to pay. The doctors could help them out for free. Okay. Now, of course, we get to Fatima al-Fihri, who basically, her dad was a successful merchant, and then he died and left her his wealth. It's kind of like the De Soto Masjid down outside of I-30 down in Dallas. Oh, for the Dallas people, they know about De Soto Masjid. Just like that, like basically a male relative died and left behind the wealth, and in this case the daughter, in that case the wife. But with Fatima al-Fihri, she was the daughter. She used that money to make a masjid, and in that masjid she built the first university. And so many people studied in that university. There was a pope, I think his name was Severus, he studied in this university. There was a Jewish scholar named Musa ibn Maymun, also known as Maimonides. Basically, he's one of the most famous Jews in Jewish scholarship, and he basically wrote a lot of works, and he studied in this Islamic university, in this madrasa, basically. That's why a lot of Musa ibn Maymun's, a lot of Maimonides' works looks like it's basically based on Muslim books. Of course, there's Al-Zahrawi. Al-Zahrawi was a surgeon. He wrote Kitab al-Tasrif. Basically, Kitab al-Tasrif is a 30-volume encyclopedia of medical practices. 30 volumes. One of these volumes was translated to Latin and became a standard textbook in Europe for many centuries. The book became the standard textbook in Europe when translated to Latin, as I just said. And a lot of the instruments that he invented, like scalpels and stuff, are still used even today. Now, one thing I want to get at, I probably mentioned how there was a lot of Greek works and Indian works that were borrowed, right? Like Al-Khwarizmi read about a lot of Greek works and Indian works, and the Banu Musa brothers read a lot of Greek works, and like a lot of Greek, and of course, other people came to learn from the Muslims. Greek and Indians and Iranian and African and Egyptian and Babylonian works were all used. Now, here's the thing. Muslims did use people before them, but so did the people before us. In fact, the Greeks learned from the people of Egypt and Iraq. In fact, Greece was basically culturally a part of the Middle East. And that's why it's not like Greece was culturally European back in the day, back before the Muslims. In fact, the land of Syria and Palestine, a lot of people there spoke Greek. And now it's Muslim. Now, Ibn al-Haytham is another famous person, right? Now, he had a lot of talents. One of them was civil engineering. However, there was a crazy Fatimid emperor. There was a crazy emperor in Egypt. Basically, after the Ahmed ibn Tulun and his dynasty, the Fatimids took over. Hey, by the way, first off, does anybody have any questions? Oh, what is a merchant? A merchant is basically somebody who sells things, who buys and sells. It's like a trader. It's like they didn't have grocery stores back then. However, have you ever been, if you've been out to a marketplace, it's full of merchants. The people selling there are merchants. Yeah, she made the first university. How long is this class? 1 hour. Will we do a Kahoot? Yes, we will do a Kahoot. Yes, we will do a Kahoot. These eyes are really hard to memorize. Yeah. I did do a summer work. Okay, but yeah. Like it was how old was who? The merchant? Oh, wasn't Prophet Muhammad a merchant? Yes, the Prophet did work as a merchant. Yes, I did teach a Sirah class over the summer where I talked about the Prophet Muhammad being a merchant. How old was he? How old was who? Okay. Oh, sorry, I meant to write so. This is a typo over here. So basically, the story goes that Ibn al-Haytham took a job with the Fatimid emperor. Now, al-Hakim was really weird. One thing al-Hakim did is he made a law that night is day and day is night. In other words, everybody had to trade at night and sleep in the day because al-Hakim made that the law. Al-Hakim also made a law that, oh, he didn't like this kind of woman's shoes. Nobody's allowed to trade anymore. Al-Hakim did a bunch of weird stuff. And therefore, he was a little crazy, right? Now, Ibn al-Haytham took up the job. Al-Hakim ruled over Egypt. Ibn al-Haytham took the job to go to Egypt and figure out the flooding of the Nile. And he wanted to build a dam that basically controls everything. Now, Ibn al-Haytham did look at the whole dam, and he did look at the whole river, and he was like, you know what? This actually may be harder to do than I thought. But the thing is, Ibn al-Haytham would be really mad. So what Ibn al-Haytham did is he pretended to be insane so that Al-Hakim was going to be really mad. So Ibn al-Haytham pretended to be insane so that Al-Hakim won't do anything to him. I don't know exactly how old Al-Hakim was, but he was Umar ibn al-Khattab. You know, all of these people were a lot of ages when they lived lives. Like, well, the dam couldn't have been big because it wasn't fully built, at his time at least. Now there's dams like the Aswan Dam. But okay, one other thing Ibn al-Haytham did is he developed the scientific method. He was like, oh, we need to calculate things by experimentation and all that. Instead of being all philosophical, we need to do experimentation. And that became the scientific method. He also founded optics. Optics is a study of light. Now, before Ibn al-Haytham, under the Greeks, hey, by the way, if I'm going too fast or you're not understanding me, let me know. Okay. Now Ibn al-Haytham basically saw the Greek. He read a bunch of Greek works. Some Greeks were saying, "Oh, okay, light comes out of our eyes, and that's how we see." Other Greeks were saying, "No, no, 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 no. Light comes into our eyes." Other people were saying, "Oh no, this. Oh no, that." Ibn al-Haytham basically read all of them, and he was like, "You know what? Actually, light. A lot of points of light from different areas comes into our eyes, and that's how we see color. That's how we see everything." And he built something called the camera obscura. If y'all see this picture on the right side of the slide, you see there's a little small building with a little hole, and because of the light that comes out, it creates a bit of a upside down image. This image is basically a reflection of what's outside, and this is called the camera obscura. Ibn al-Haytham built a really good one. Now, Ibn al-Haytham was also religious, so he wrote a book on how to figure out if somebody's a false prophet. And he also wrote works on gravity. It seems that his works on, not on gravity, per se, but it seems that his works were used by Newton for Newton's theory of gravity. Because Newton did base a lot of Newton also wrote a lot on optics based on Ibn al-Haytham's works. Ibn al-Haytham is also referenced in the English Canterbury Tales, written in Middle English. And it seems that a lot of his works inspired the English scientist Isaac Newton. Now, one of the contributions that he made is that taqlid, meaning blindly following, like just doing whatever you're told, should only apply to Islamic figures like prophets and not to Greek philosophers. Let me see if anybody else. Oh. Okay, sorry. I do speak too fast. All right, I'm going to slow down. No, Ibn al-Haytham was before Isaac Newton. Isaac Newton read Ibn al-Haytham's works. You wouldn't have optics means the study of light. It's basically how you see things. Oh, that's cool, Faizan. You made it okay. Who was the person who was the first surgeon and writer of the 30-volume series? That was al-Zahrawi. Okay, I'm sorry. I'll slow down for the people. It's okay. Now, okay. Who created algebra? His name was Al-Khwarizmi. Let me just go up the slides real quick so that y'all can see. Al-Khwarizmi developed algebra because he needed to calculate inheritance and zakat. And he popularized Indian Arabic numerals. The Banu Musa brothers, they wrote the Book of Ingenious Devices, and they also diverged from Greek. Ibn Firnas, for first intercontinental flight, and he found a way to make colorless glass so that people could make he made reading stones, and from there you got glasses. Ahmed ibn Talun, he became the governor of Egypt, made Egypt independent. No, Ibn al-Firnas did not fly a whole continent. He only flew like from one continent to another. Like it was a very small distance, but we now call it 2 continents. I think it was like I want to say it was from Spain to Africa to Morocco, which is very short distance. I may be wrong though. I don't really remember which continents it was, but I think it was from Spain to Morocco. Okay. Al-Zahrawi. Now the person who wrote the 30-volume book was Al-Zahrawi, and he made instruments still used today. Now Ibn al-Haytham, okay. Ibn al-Haytham basically wrote that we should only follow Islamic figures, but with Greek philosophers, you need to rethink through. You need to be like, oh, is this guy really talking about what he's saying? Does this guy really know what he's saying? Maybe the Greek philosophers can be wrong. Only the prophets are always right. That's what Ibn al-Haytham said. And this is actually really important. Okay? Now, another person was Maryam al-Ijliya bint al-Ijli. She made something called astrolabs, astrolab. All right? She learned how to do it from her father. Okay? Now, basically what an astrolab is, it's basically you match it. There's like This is called the It's a the base is called the In there you have a bunch of smaller plates, and you try to line it up with the horizon, and then there's markings on it that match up with the stars on the sky. And then you can use, and then once you do that, once you calibrate it, once you match it to the horizon and match it to the stars in the sky, then what you do is you can find the qibla, you can find salah timings, like you can find when to pray, you can find when to plant crops or raise taxes, or even when the tides rise. You can it's basically like a lot of things you do now on your phone, you basically did back then on an astrolabe. And Maryam Majid, she basically advanced it by a lot. What's a horizon? A horizon is okay. If you've ever been outside, you see that there's a part when you look far away in the sun during the sunset. There's a part where the sun goes down. Because the Earth is round, you don't all the way like from here. You don't see Mecca. You can't see Mecca, right? Because the Earth curves. So instead, you only like your eyes only go to a certain level, and then you can't see the ground anymore. And so when the sun goes down, it looks as if the sun is setting in that part because the Earth is round, and that part is called a horizon. Okay, Al-Bayruni. Now, one of the things he did is he separated astronomy from astrology. Yes, horizon, the place where the land and where the sky and land meets, like, or at least that's how we see it. The place where it looks like the sky and the land are meeting. So when you draw a picture and you basically make the land end and the sky start, that's called a horizon. Now, Al-Bayruni, he separated astronomy from astrology. Do you know what that means? Okay, astronomy is the study of the sky, of the stars, of basically all the stuff in outer space. That's astronomy. Astrology is how it all affects us. But here's the thing: before the Muslims, people saw this as the same thing. They were like, oh, this constellation, oh, this guy was born in this month, and therefore he's a Leo, and the Leo is having this future, and the Leo's like this. Al-Bayruni was like, nope, this is stupid. Al-Bayruni was like, no, the stars are their own thing, the planets are their own thing, and we're our own thing. And so that's called. And so he was like, oh, this is astronomy. Astrology is something else. So that's what he did. Now what? Now he also debunked Aristotle, because Aristotle said that, oh, he was basically calculating on the way planets move and stuff, and he was like, no. Aristotle was like, no, this something is impossible, because then vacuum would happen. Al-Bayruni was like, no, Aristotle's wrong. Who says that vacuum can't exist? Vacuum means that there's no air, no water, no nothing, right? Like in space, it's vacuum, right? A lot of parts of space is vacuum. Aristotle basically, Al-Bayruni basically said that vacuum is possible, and if Aristotle is modeling the whole universe based on this assumption that vacuum does not exist, then Aristotle is wrong. Oh, debunked means to prove it wrong. Aristotle is a Greek guy. He is somebody from Greek philosophy. He was a Greek philosopher from back in the day. Basically, Aristotle, a lot of what he wrote was borrowed by some Muslims like Ibn Sina, who basically copy pasted it, and then a lot of other Muslims like Al-Bayruni were like, nope, Aristotle is wrong, and basically he advanced it, right. Now, one thing that Al-Bayruni did is he calculated the radius of the Earth. So this R over here, if this is the Earth, this circles the Earth, this R is radius of the Earth. Al-Bayruni basically calculated the radius of the Earth based on the height of a mountain. He was like, yeah, this mountain is this high, and therefore this makes it right. If I see it like from a right angle perspective, okay, whoever is, yes, we will have, okay. Al-Bayruni basically said that, oh, wow, if this mountain is this high, I can calculate the radius of the earth, meaning I can calculate the distance from us to the center of the earth. And he got really close. But because he got really close, then once he found the radius, he calculated the circumference of the earth. Y'all know what circumference means? Circumference means the length of the side of a circle. Like this little curvy part over here of the circle, how long is it to go all the way around? Basically, Al-Bayruni was like, oh, okay, with this radius, I can calculate that it takes the entire circle of the earth would take this long to go around. And then Al-Bayruni was like, wait a minute. If the circumference of the earth is this high, then Afro-Eurasia, Africa, Europe, Asia, all that area, is only 40%, is only a small part of the earth. That means there's a whole other side of the earth that's the majority of the earth that we haven't even been through, right? And therefore Al-Bayruni was like, you know what? It only makes sense that there's another continent on the other side of the world. And of course, that's America. No, the radius is radius is half of the diameter. Circumference is pi times the diameter. Well, by the way, a lot of people knew that the earth was spherical since before Islam. It's people all knew it. It was like if you're on a ship and you're sailing away from a city and you notice that the bottom of the city is disappearing, you'll be like, oh wow, the earth is round. Al-Bayruni was alive around the 900s. I didn't put the years of their birth, but I'm going in order. So Al-Khwarizmi was alive during the 800s. The Banu Musa were like 800s. Ibn Farnas was then. Ahmed ibn Tulun was like 900s. Fatima al-Fihri was around then. Al-Zahrawi was it? Ibn al-Haytham was like 1000s or 1000s. Now Al-Bayruni would be around then. Like I think Al-Bayruni would have been around I want to say 1100s. But it was medieval. It was about 1,000 years ago, less than 1,000 years ago. Okay. I'll okay, afterwards, after we go over the slides, I'll tell y'all when everybody lived, okay? Now, but the thing is, Al-Bayruni basically calculated the radius of the earth. Oh, sorry. He basically was like, oh, there should be a continent on the other side of the world. And now we live in that continent. Basically, Al-Bayruni knew that there was knew about where we live long before our ancestors actually came to live here. Back when there were only Native Americans living here. Now, and Al-Bayruni was one of the first people, Al-Bayruni was one of the first people to basically divide the hours into like base 60 digits. And he divided the hour into minutes, seconds, thirds, and fourths. People who already counted by hours, but Al-Bayruni was the worst to divide it according to this minutes and seconds. He was writing a book on the Jewish calendar, and that's how he divided it. And he also wrote books on the history of religions, and he wrote books on Indology, which means the study of India and the Indians. Al-Bayruni basically traveled. He talked to many Hindu, like what we now call Hindus. He sexagesimally basically means base 60, by the way. But Al-Bayruni basically talked to a bunch of Indians the study of India and India. Like he basically wrote a lot. But the thing is, when Al-Biruni was talking about, when he was writing about them, he wasn't writing like, oh, this is why they're wrong. He was like, yeah, we know they're wrong. We already know that Islam is true. However, this is still something really cool about these guys, because during Al-Biruni times, every Muslim knew that Islam is true. Everybody had confidence in Islam, because like it was so easy to have confidence in Islam. So Al-Biruni didn't need to like refute them. He just was like, you know what? This is actually something pretty cool about the Zoroastrians. This is something cool about the Buddhists. This is something cool about Christians. Stuff, and this is something cool about Jews. All right. Yes, Al-Biruni was 973 to 1048. Okay. Al-Khwarizmi, yes, 780 to 850. Somebody asked what Jews are. If there's a class on the world religions, you should we'll get to that. Okay. Jews are Jewish people, like they're offshoots of Bani Israel religion. Now, okay, we're almost out of time, so now, okay, first there's Al-Jazari, okay? Okay, back then, mechanical engineering is a lot like art, okay? So Al-Jazari made a bunch of stuff that used water to work, right? They call him the father of robotics now. Now, one of his most famous things that he made is called the elephant clock. Now, the way the elephant clock worked is inside this little elephant. Now, these weren't actual elephants. This is not an actual dragon. This is a model, right? Now, inside the elephant, there's a bit of water over here, and the water had a bowl with a hole in it. The hole would make the water basically come all the way up, and the hole would come all the way down. The bowl would come all the way down. Now, the bowl was connected to a rope, so every time it came all the way down, this phoenix would start spinning. A ball would come hit, and the hour would change, and this over here, this guy over here basically measured like the minutes, and then the ball would come and hit the dragon, and the dragon would go, and this guy would keep moving. Okay. Yes, Ibn Firnas is from 810 to 887. Now, this guy would move, right? Now, Al-Jazari basically said that when he made this, he used the elephant to represent Indian and African cultures. He used the two dragons represent Chinese culture, the phoenix represents Persian culture, the waterwork represents Greek culture, and the turban represents Islamic culture. In other words, Al-Jazari knew that Islamic contributions and all contributions are made by taking what already exists and advancing it. Now, of course, we have Al-Idrisi. He lived in Sicily. Sicily was now under Muslim rule before, but now is under Christian rule. Sicily is basically part of Italy now. It's a part that the Buddha is kicking, basically, if you look at the map. Now, Al-Idrisi created this map and a bunch of other maps called to write the Tabula Rajarina, which is one of the most advanced medieval maps. I think, well. Now, one guy that's really important is Nizam al-Mulk, okay? Nizam al-Mulk was the prime minister of the Seljuk Empire. All of y'all who watch Ertugrul probably know about the Seljuk. Before Ertugrul, the Seljuks became really cool because of Nizam al-Mulk. Now, Nizam al-Mulk went to a madrasa as a child, and he had some scholars who were friends. And he wanted his friends to become amazing teachers, right? So his best friend was named Imam al-Juwayni. So Nizam al-Mulk had this idea. He was doing a lot of things, and he was like, okay, I'm gonna make not just a university, but a university system where a lot of schools, a lot of universities all work together and have the same curriculum. And so he created that, and he put his best friend Imam al-Juwayni as the leader, as the first principal of the first one, right? Then he was like, as a rector, right? Then he made one in Baghdad, the capital, eventually. Like the final one was in Baghdad, the capital. And he was like, you know what? He went to his best friend Imam al-Juwayni. He was like, okay, I just made one in the capital city, Baghdad. or in the intellectual capital, I need to make somebody who is really good. I want you to give me your best student so I can make him the principal in Baghdad. And so Imam al-Juwayni picked out Imam al-Ghazali. Now remember Imam al-Ghazali's name because I'm going to get back to him in a second. Okay. Now Ibn al-Shatir is another person. Ibn al-Shatir was a muwaqid, a timekeeper. His job was basically, he wanted to be better at telling the prayer times. He wanted to be basically is like, oh, the muadhin should give the adhan now. The muadhin should give the adhan then, right? Now, because he wanted to be better at calculating the prayer times, he figured out that the hour should be the same all year. Basically, when the Greeks had it, some days the hours would be shorter, some days the hours would be longer. Ibn al-Shatir was like, you know what? I'm gonna create a clock, a sundial, like a clock, that basically has the same time hour every day of the whole year. So he made us, if you see the background image over here, he worked at the Umayyad Mosque in Baghdad, and he made the sundial that basically works. It basically gives the same length hour throughout the whole year. And another thing he did is he looked at space, and he developed models of planets. Model of planets that Nicholas Copernicus would have used later. Nicholas Copernicus was a guy that basically figured out that the sun is in the center, right? Ibn al-Shatir basically paved the way for Nicholas Copernicus to do that, based on what he did. And Ibn al-Shatir did whatever he did, all because he wanted people to pray on time, because he wanted to make Islam easier to follow. We'll have Kahoot soon. Let me just finish this. Another person was named Ulugh Beg. He was the grandson of Timur and the oldest son of Shahrukh, right? There was an empire called the Timurid Empire. Basically, what you have is you had the Mongol conquest, and the Mongols basically destroyed a lot of things. Then a guy named Timur basically conquered a lot of land, and then eventually there was something called the Timurid Renaissance. And Ulugh Beg was a sultan, and now he wrote. Now, when you're in high school, you'll learn what sine and tangent are, and you'll understand why what he did was so cool. And then he basically looked at the stars and how they are year round, and he said, okay, if we calculate years based on the stars, it's 365.257. He basically was off by 58 seconds. And then he said, okay, and if we calculate the year based on the seasons, he gave the 365 days and but he was off by 25 seconds. And he was also a leader, like an actual sultan. Now his student was named Ali Qushji. Now remember Imam al-Ghazali? Imam al-Ghazali did not like Aristotle, and he rejected Aristotle physics. And because Imam al-Ghazali became the principal of the main school, a lot of his students also hated Aristotle. So Ali Qushji did not like Aristotle. So he basically was like, okay, he took Aristotle out of astronomy, and he basically made astronomy pure science. He took the philosophy out. And then looking at the comet, he figured out that the Earth rotates, and a lot of his works may have inspired Copernicus. In other words, Ali Qushji basically made scientific advancements because he wanted to make scholars happy, and so he separated science from philosophy. Now, of course, there's Ibn Khaldun. Oh, can I go back? Go back where? This guy? Yeah, we're just gonna do the Kahoot in a minute, and like, let me just finish this. Okay. Now, Ibn Khaldun wrote a book called the Muqaddimah. Muqaddimah is just an introduction to history, right? Basically, a lot of his works called Supply and Demand and stuff, it's used. I have his book with me right now, actually, English translation, but we should probably get to the Kahoot, so I'll probably go over it. Now, there's a bunch of travelers like Ibn Battuta who traveled throughout Eurasia. Ibn Fadlan, who basically visited Vikings in what is now Russia or Ukraine. Zheng He lived under the Chinese Ming Dynasty, and he made 7 voyages in Muslim lands in Asian Africa. And Olivia Jelebi, he wrote a book about his travels through the European subcontinent. And when he was in Europe, he met Native Americans who basically complained about the European invasions of their homeland. And they were like, we were much happier before the Europeans came to our land, and now we die sooner. Olivia Jelebi wrote about this in his book. He was Turkish. Now, conclusion. Many Muslim scientists made their contributions in order to make Islam easier to follow. Many advancements were done because people were trying to make scholars happy. Many scientists were themselves scholars. They were themselves ulama. They studied both Islam and science because it was the same thing back then. Any knowledge that you have, any knowledge can have the potential to have value. All knowledge can be beneficial if you make it so. The advancement of knowledge is based on taking what exists and building upon it. Knowledge grows exponentially. We may not see the value on like what people did 1,000 years ago, but people 1,000 years from now, they will see us the same as people from 1,000 years ago. They'll be like, oh, smartphone, algebra, what's the difference? Smartphones, sundials, what's the difference? Because they'll be so advanced in the future. And each of us, all of us, has a potential in advancing knowledge. We can all do our own things. We can all make an Islamic Renaissance. We can all make our own things. Now I'm gonna try doing the Kahoot game now. Okay, so that's the whole slide. Y'all want to play the Kahoot game? Okay. So got it. Muslim contributions quiz. Classic mode. Okay, guys, join this game. I think it might be like that because of Halloween. I don't know. Okay, is everybody in? Okay. Okay, I'm gonna start. I'm gonna start in 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Which of the following describes how technology grows? Exponentially. That was the beginning part of the. All right, it was a hard question. It's okay. Which of the following battles led to the adoption of papermaking technology by the Muslims? Good job. The Battle of Tellus. The Battle of Hunain is close though, but the Battle of Hunain was when the Prophet adopted other stuff, not papermaking. But the Battle of Tellus is, yeah. During the Battle of Hunain, Rasulullah Sallallahu Alaihi Wasallam adopted these innovations from other civilizations like the Romans, except good job. Which of the following is known as the father of algebra? Good job. It's Al-Khwarizmi. Which of the following is not a name of one of the Musa brothers, Banu Musa brothers? Does my screen keep freezing? Yes, Ali. Ibn al-Shatir built a sundial with the same hour all year. Copernicus uses astronomical models. What was his main job? Wow, nobody got Shinobi. Okay. But yeah, wow. Okay, most people got this right. Which Timurid Sultan was an astronomer who built the largest observatory in Central Asia during the Timurid Renaissance? Good job. Yeah, Timur was the founder of the empire. Ulugh Beg was the actual sultan who did this. Which of the following were not included in Ulugh Beg's contributions? Good job. Which of the following was Ulugh Beg's student? Which of the following was one of Ali Qushti's contributions? The code is 12 questions, by the way. He found evidence of the rotation of the Earth based on observing comets. Good job. Oh, by the way, the ones who said he completely adopted Aristotle, he rejected Aristotle. He wanted to get rid of Aristotle from astronomy. True or false? Technology is advanced by completely ignoring what already exists and starting from scratch. There you go. True or false? Anyone in this audience has the potential to bring back an Islamic Renaissance. You can bring back another Muslim golden age. You just have to seek knowledge first. Good job. Let's see who won. Habiba got 10 out of 12 questions correct. Safu got 10 out of 12 questions correct. And Wafiq K got 12 out of 12 questions correct. Good job. Good job. Yes, I do watch Naruto. Okay. All right, inshallah, I guess that's everything. Does anybody have any questions? Yes, I do have TikTok. No, I think that's it. Is there anything else after this?
Yes. Jazakallah khair. May Allah give you the best reward. I'll conclude the session with a surah and dua. أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم والعصر إن الإنسان لفي خسر إلا الذين آمنوا وعملوا الصالحات وتواصوا بالحق وتواصوا بالصبر سبحان ربك رب العزة عما يصفون وسلام على المرسلين والحمد لله رب العالمين. جزاك الله خيرا. السلام عليكم ورحمة الله.
وعليكم السلام ورحمة الله وبركاته.